Hi, and welcome to the Dilation, Erosion, and Edge Detection practical aspect where we implement these in OpenCV. Okay, so let's start our actual practical exercise here on Dilation, Erosion, and Edge Detection. So open this file, type number 9, and here we go. So it's a rather simple exercise we're doing here. So what we're doing, we're loading the OpenCV text that I showed you guys before, and we're displaying it, and then we're defining kernel here, 5x5 kernel, and I'll show you how it's used afterward. We'll change it so you can actually see the difference. So left this out, dilate here. And now what we do, we can actually specify a number of iterations, which is how many times you erode the image. Similarly in dilation here. So what we're doing, we're using cv2.erode, cv2.dilate. For the opening, we use cv2.morphology here. And you can specify the algorithm being used. This is the default one, and the one that does open, the one that does close, and you can use the same kernel we defined above. So let's take a look at these, how these will affect the image. So this is our original image here. It's nice and clean. This is our eroded image. It does exactly what we expected. This is our dilated image, also does what we expected. Let's just space this out. And now let's do the opening. Remember, opening is erosion followed by dilation, which is why it looks like this, and we erode, we dilate here. And then let's do closing, which is dilation followed by erosion. So basically this eroded, so it's quite good. So it's oddly similar to the original image. Okay, so that's a good experiment, that's fine. Let's now change the kernel size to 3 by 3, and let's take a look, see how that affects things. So you can immediately see there's less erosion, less dilation. Opening and closing pretty much similar. Remember before, without opening looked a bit messy. Now it's actually a bit better. So now let's make this even bigger, so you can see more pronounced changes. Let's change it to 9 by 9. Wow, eroded it. It disappeared effectively. Now this one got a lot thicker, like a fat marker type font used. Now remember, apparently there's some pixels. Yeah, there's a couple pixels here. That this is basically opening is erosion followed by dilation here. So these little tiny pixels here that you're seeing, barely see it, so hopefully your video quality is good enough. We're eroded into these little blocks here. And now, as I expected, it's going to be quite good because it's already thick. So if we dilate something, even if we dilate it a lot, it's going to be fine. So now let's go back to our 5x5 and let's change one thing. Let's do 3 iterations of each. What do you expect? Yep, exactly. So you can see, you can toy with these little parameters to basically experiment with your own erosion and dilations and different kernel sizes and different number of iterations. So now let's move on to edge detection and image gradients. So what we're going to do first here, we're going to use cv2.sobel to get the x edges and the y edges here. And basically how this function works here, you basically specify 0, 1 here if you're doing the x edges, 1, 0 here if you're doing the y edges. And case size determines the kernel size used here. So don't think about these parameters too much. Just, as I said, Sobel isn't used a lot anymore, but it's kind of fun to use anyway. And what we're doing here, we do a bitwise OR on the Sobel X and Sobel Y extracted edges. So we can just do Sobel all, alright? And you can take a look at that. And then after, we're doing a Laplacian edge detection algorithm on the same image here. And lastly, what we're going to do at the end, we're going to run canny edges on the image here, okay? And what I will do, I'll explain to you afterward the threshold values of canny edge detection so we can actually toy with them in this tutorial and see if we can get some better results. So let's run through this edge detection code and look at some of the edge detection algorithms and compare them. So this is our original image here. Now let's look at the Sobel X. Remember, it looks at the horizontal edges and it's not too great here. Maybe we can refine that afterward. This is Sobel Y, again not too great. This is both of them, kind of poor. This is Laplacian, again it's a bit messy, very messy I should say. And now let's look at the canny edge detection, which is like wonderful. It's actually perfect, okay? So you can see how much better canny edge performs compared to the other algorithms. Now let's take a look at the experiment here with the canny edge code. So let's load our image here. We don't need that, we don't even need to import it, but might as well. Okay, so let us do a few different versions of the canny code, okay? So let's set this to maybe, let's do some wide thresholds. So what wide thresholds are going to do So we're going to experiment with a few different canny values here. So this is going to be canny, let's go wide range here, 10 to 200. This is going to be canny, let's say like a narrow range here. And this is probably going to be similar to what our original image, actually it is similar, it's the exact same thing. So let's probably make it a little bit tighter. Let's make it 70 to, let's say 110, okay? It's not going to be much different, okay? How I will describe something to you guys is that the thresholds here specify lower and upper boundaries of gradient values, so it's a little bit hard to interpret unless you read the paper or look at the mathematics behind it. But you can get a feel of what it is and what it's doing by experimenting with different values, which is something I always encourage. So let's take a look and see how a canny performs. So this is the initial default values we have, which usually work pretty well. This is our canny wide, which should be capturing more edges, and it doesn't seem like it is. Actually, it's less edges. Do you know why that would probably happen? It's odd, but it's probably because of the definition of the gradient that it's using for the edge detection. So let's take a look at this one. Narrow actually captured definitely narrower, less edges here. So it's actually a bit better, I would say. And where is the third one? Oh, it's basically replaced. I forgot to rename the window. Always just remember, by the way, it's a good thing if you've seen this. If you don't rename the window to something new, ImShow is going to basically overwrite the window with the same name, which is the first window here. So let's run that again so we can actually see. This is called as candy tree. So let's see it again. There we go. So it actually is a bit different to the original here. So you can see how changing these thresholds create different edges or get different edges from the image. Alright, so that's it for this video. Let's go to the learning summary for this chapter. So what we've learned here is how to perform dilation, erosion, opening and closing in OpenCV. And then we took a look at edge detection and how we use image gradients. And then we took a look at Sobel and Laplacian, and then looked at canny edge detection, which performed a lot better than the others. So I hope you enjoyed this video. And now you can stay tuned for section 3, where we take a look at image segmentation and object detection in OpenCV. Thank you.